Okay, so we're going to begin chapter 7. Chapter 7, titled Cellular Respiration. Excuse me. Cellular respiration, as we're going to see in this chapter, is about how to make energy molecules, how to take energy from one form, change it to another, following the 2 laws of thermodynamics we learned in chapter 6. So, you've eaten. You've taken in food within the bonds of the polysaccharides, the proteins, the nucleic acids, everything. There's energy. Energy holding the molecules together. It took energy to link them. It's going to take energy to break them. And in the process, you're going to get some energy back. Going to notice that, well, when it comes down to it, that the breaking of the bonds and the making of energy is going to be linked to ATP. Okay, ATP is it's a medium term, medium time storage device used by all living cells on this planet. Short term, we're going to see, is going to be, little things that, NAD, FAD, that are just there for seconds and that's it. Long-term storage is going to be in the carbon-carbon bonds of fatty acids and the like. So throughout this chapter and the next chapter, pay attention to where is the electron. Who's got the electron? Who's got the high energy electron? Where's it going? Because it all comes down to what are referred to as redox reactions. Reduction and oxidation reactions. I always use the stupid analogy. You remember as a kid playing that game, hot potato, right? You toss around the ball, you toss around whatever, and whoever ends up with it is out. Okay, that's hot potato. Well, here, instead of a ball or a bag or something like that, it's an electron. Who's got the electron? Where is it going? Where's it going to end up at? Now, keep in mind, though, in the back of your mind, whenever I say electron, what I'm actually talking about is a hydrogen. Because that's something we find in biological systems. It's not always the electron being stripped off of a valence shell and moved around. A lot of the times, it's going to be the hydrogen. Remember, hydrogen is nothing more than an excited electron and a proton just coming along for the ride. So you look at, up here, this equation. AH plus X will yield A plus XH. A gave up the hydrogen, X accepted the hydrogen. Past the potato, past the electron, past the hydrogen. So as the hydrogen is being moved around, okay, to be moved around, it's going to take enzymes, as we're going to see in this chapter. And the enzymes, once they get the excited electron, the hydrogen, they need to park it someplace, okay? Because the enzyme's job is just to pick up the hydrogen. It's not to move it around, do things with it. It pulls it off of one thing, needs someplace else to put it. So it's going to sometimes use what are referred to as carriers. Carriers are going to take those excited electrons, that hydrogen. It's going to move it from A to X, whatever X is. Sometimes A and X can be in the same organelle. Other times they're going to be in different organelles, someplace else within the cell. These electron carriers are going to do exactly what the name says. Carrier transports. Takes package from point A to point B. Here the package is an electron. What's moving it? NAD, as we see, here. Now, these electron carriers are nothing more than transports. Okay, they're not storage mechanisms. Okay, they take the electron, they move it to where it needs to go, they get rid of it, and they do so quickly. As we're going to see later in this chapter, these electron carriers are finite. Okay, there's not an overabundance of them. So there's only so many of them that's available within the cell. So the cell needs to keep them moving, keep them picking up, delivering, coming back for more over and over and over. You see here, FAD, NAD are our two electron carriers of choice. NAD, as the figure shows, on the left, NAD plus, and on the right, NADH. If you see FAD or NAD alone, with or without that plus, that means it hasn't picked up yet. When it ends in an H, FADH2, NADH, that means it has an excited electron and it's in the process of transporting it somewhere else. One thing to notice right here, NADP and NAD are two different things. NAD you're going to find in animal cells. NADP has an extra phosphate on it, and it also is only going to be found in plant cells. Pay attention right here. Notice NAD hasn't been reduced yet. To be reduced means it has the hydrogen. To be oxidized means it lost. There it goes from 1 to 2. That's it. That whole big thing of 6 dozen atoms. 1, 2, 3, 4 large molecules. 2 macromolecules. All to carry 1 hydrogen. Carry 1 hydrogen stably. That's it.